All right, so last part of the lecture. We're going to look at a couple clinical applications. We've just spent the last part talking about how we keep a stable blood pH and stable body fluid pH. We're going to look at what happens when there are imbalances, when they don't stay in the normal range. So I mentioned a few times last time that normal blood pH is 7.4. All right, so it's just a little bit basic, just a little bit above neutral. It says if the pH of arterial blood, so blood in our arteries, drops to 6.8 or up to 8, if it rises up to 8 for more than a few hours, usually we don't survive. We'll slip into a coma and our body can just shut down and we die. So it's very important that we keep pH in that really narrow range. So 7.4 is healthy. If we drop down to 7.35, that's not very far at all, just a little bit down to 7.35, there's a condition called acidosis which can occur. All right, so that means that our blood is a little bit more acidic than it should be. It's lower than it should be. So acidosis can occur. We're going to look in more detail about that, but it causes symptoms like drowsiness, disorientation, stupor, which is where your brain doesn't function right. You have lack of cognitive function, so you can't think. You might start to forget things. Now, 7.4 is normal. If it goes up to 7.45, so just a little bit higher, then that can cause a condition called alkalosis. Remember earlier we said alkali is another word for basic. So if it becomes too strong of a base, alkalosis can set in. That causes, the other one was kind of like slowing down, so drowsiness and disorientation. The other one is almost like an anxiety type feeling. So it's lightheadedness, agitation, dizziness. You might feel physical tingling. So the way this works, and this is what we're going to look at, you can have, for acidosis, if you have an accumulation of acids, so too much acid is building up in your body, or if you lose too much bases, then that can cause an increase in the hydrogen ion concentration. That makes your pH go down and can lead to acidosis. For alkalosis, if you lose too much acid or if you build up too much base, either one of those is going to decrease the concentration of hydrogen ions. That means that your pH is going to go up, and that causes alkalosis. So one more time, remember, the more hydrogen ions you have, the lower your pH is. The less hydrogen ions you have, the higher your pH is. Okay, so we're going to look at acidosis first. There are two different categories of acidosis, and they are going to be based on what causes them. So the first one we're looking at is called respiratory acidosis. So respiratory, that tells us it has something to do with breathing. All right, so let's look. It says carbon dioxide levels increase. So something with the breathing is making our carbon dioxide levels go too high. We mentioned earlier that carbon dioxide leads to carbonic acid. So carbonic acid levels are going to go up, and that makes our pH go down. Our responses to that, these are all the things that we mentioned earlier. So we've got chemical buffers that are going to kind of bump the pH back up to where it should be. We're going to stimulate our respiratory center, so we're going to start breathing faster and deeper. And then lastly, kidney excretion of hydrogen ions. So our kidneys are going to dump out those hydrogen ions. So that's what we do to try to fix it. Symptoms, like we said earlier, are drowsiness, disorientation, stupor, so brain function is not working properly, and labored breathing. So remember, we're trying to breathe faster to get this carbon dioxide out, so you're going to be breathing really deep and really fast. There are a couple causes for this. Now, these should not happen normally, but the causes can be an injury to the respiratory center of the brainstem. So the part of your brain that controls how you breathe, that might be damaged. That means that you're probably not going to breathe fast enough to get the carbon dioxide out, and that would lead to the decrease in pH. Obstruction of the airways. So if you're suffocating, if something is blocking your trachea and you can't breathe, then you can't remove carbon dioxide. Or lastly, it could be diseases that decrease gas exchange. So things like pneumonia or emphysema. Your gas exchange is not going to happen the way it's supposed to. That means that you can't remove the carbon dioxide from your blood. You can't transfer it to your lungs. And that could lead to a decrease in pH, which would be acidosis. All right, so all of those, if you'll notice the causes, had something to do with breathing, which is why it's called respiratory acidosis. The other type of acidosis we're going to look at is called metabolic acidosis. All right, so these are non-respiratory acids. These are things that are making our pH go down, but it has nothing to do with breathing. So let's look at some examples. Right here it says kidney failure to excrete acid. So in the top left, I'm on my laptop. I know this cursor's probably been annoying. I can't quite control it as much as if I had a mouse. But it says kidney failure to excrete acids. So your kidneys don't get rid of acids the way they're supposed to. That's going to cause a buildup of acid in your body, and that can cause metabolic acidosis. Or it says excessive production of acidic ketones, as in diabetic mellitus. So diabetes, if you don't produce insulin, then your body is going to break down fats and fat tissue and adipose tissue. When it breaks down the fatty acids, it releases those acidic ketones that we talked about earlier. If you've heard of the condition diabetic ketoacidosis, it's a mouthful, but it's a problem that is involved with diabetes a lot. It's caused by when you break down fatty acids from adipose tissue, those ketones are released and they can make the acid increase. All right, so that's the one way we can make too much acid. Drop down to the bottom though, and there's some other causes. So it says prolonged diarrhea with loss of alkaline intestinal secretions. So if you have such severe diarrhea that you're dumping out all of the food and all of the secretions from your intestines, you're getting rid of all those bases in your body. And if you remove a base, that's going to make the pH go down. Or, and this would be the severe one, it says prolonged vomiting with loss of intestinal secretions. So this literally means, and this doesn't happen often, it's usually a really bad problem like poisoning or something like that, but you can have vomiting that is so strong that it not only empties the contents of your stomach, but it empties the contents of your intestines also. So it goes out both ends basically. And by removing that base, you can make your body more acidic. All right, alkalosis is next. So alkalosis is our body is getting too basic, the pH is going up too high. Respiratory alkalosis deals with breathing. So let's look at the chart to the right first. So things like anxiety, fever, poisoning, or high altitude, those can all lead to hyperventilation. So hyperventilation, we're breathing really deep and really fast, all right? That causes a loss of carbon dioxide, so we're breathing out too much carbon dioxide too fast. That causes a decrease in the concentration of carbonic acid in your blood, so we're getting rid of the acid. That sounds good, but if you get rid of too much acid, then you lose all of your hydrogen ions and you can become too basic, so it goes too far in the other direction. Things we have to resist this change are buffers, that release hydrogen ions. So this would be an example where the carbonic acid is going to break down and release those hydrogen ions. Or the dihydrogen phosphate is going to break down and release those hydrogen ions to try to bump the pH back down to where it should be. Kidneys also decrease their secretion of hydrogen ions. So if this is happening, you're not going to get rid of any hydrogen ions from your kidneys because you want to keep your pH in a normal level. The urine also becomes alkaline. So urine is usually a little acidic, but it can become alkaline. Symptoms are lightheadedness, agitation, dizziness, and like a tingling sensation. And finally is metabolic alkalosis. So this is alkalosis, body pH is going too high, but it's not breathing that's the problem, it's another issue. So some examples are things like gastric drainage, or vomiting with loss of gastric secretions. So we're losing some of the acids that are found in our stomach. We mentioned like the severe vomiting where you're getting rid of intestinal juices, but regular vomiting, you're getting rid of your stomach contents, and there's a lot of acid in there. So by removing the acid from your body, you're making everything a little bit more basic. Diuretic drugs can cause this too, so you make more urine, so you're getting rid of more acids. And it says antacid intake. This would be usually, hopefully, no one is taking this many Tums or drinking this much Pepto-Bismol, but you could take in so much of those substances which are bases. Tums is an antacid, which means it counteracts the acid in your body and in your esophagus. But Tums is a base, and that's why it neutralizes the acid, is because it's the opposite, it's a base. So if you add too much base to your body, then it could it could raise your pH and cause alkalosis. So symptoms are a decrease in breathing. Right, we want to decrease our breathing rate and depth because we want to keep that carbonic acid. We want to keep carbon dioxide this time because that's going to bump our pH down and get it back in that normal range. So the result, when we slow down our breathing, just to make sure you're reading this the right way, the symptoms are we decrease breathing. And when we decrease breathing, the result is we get the concentration of carbon dioxide back up into our blood. So increased concentration of carbon dioxide in the blood. All right. So there we say we're losing let me get the cursor. We're losing our acids. That causes a net increase of alkaline substances, so too much bases, and that can cause metabolic alkalosis. It doesn't say symptoms right there, but the symptoms are going to be the same as respiratory, so things like lightheaded, agitation, dizziness, and things like that. But in addition to that, we slow down our breathing to try to hang on to the carbon dioxide. Quick side note, I don't know if you've seen these, but I've noticed too many of these floating around like on Facebook and things like that, where you'll see things, people posting articles about alkaline diets, and they're saying that it's healthy for you and it can protect you from cancer and things like that. And I'm sure these people mean well when they're sharing this, but hopefully after this chapter you see why that's kind of silly. Your body has so many different mechanisms to make sure that the pH of your body fluid stays in that really close range of 7.4, that if you add alkaline substances to your body, or if you add bases to your body, you're going to convert it right back down. And if you don't, like this example, metabolic alkalosis, it can cause some pretty serious problems too. So that's complete garbage. Anytime you see anything about a diet that alters the pH of your body, or that makes your body more alkaline and protects you, that's not actually true. That's not how it works. I saw one the other day that said something to the effect of like cancer cells cannot live in an alkaline solution. And that's totally true. Like if your body pH was like 8, then your cancer cells could not develop. The only problem is your body cells wouldn't develop either, so you would die. You would die too. So that's not something you want to do. I don't think it hurts anything because your body's going to get back to that normal range where it's supposed to be anyway. But you're definitely not going to make yourself healthier by changing the pH of the food that you eat. All right, so that is chapter 21. It's a little bit shorter than some of the other ones. So definitely go back, review this, make sure you feel pretty comfortable. And if you've got any questions, you can either send me a message on Blackboard or you can ask me on Monday. Now, our test is Wednesday. So I'm recording this on, it's the 5th, which is the day that class was canceled, but our test is going to be on the 12th. So if you've got questions, you might want to go ahead and send those to me. You don't want to wait until a couple days before the test to do that. On Monday, we've got one more PowerPoint we're going to go through, which is just some conditions that deal with what we've talked about today. And if I don't change it, it's going to be like 9 slides. So it's going to be very short. We'll have plenty of time to go through. We've got a lab on Monday, but we'll also have plenty of time to go through any questions you have and maybe do some short answer practice questions. But go ahead and look at this. Like I said, I think this was better than trying to rearrange our schedule, so look over that. And hey, the good news is the Braves play tonight when we would be in class, so feel free to watch them instead of being in class talking about pH. All right, so hope everybody stayed safe. Let me know if you have any questions, and I'll see you next week.